taking the derivative of a natural log multiple terms, okay? With natural logs, just like e's, we want to make sure that we simplify first. It will make it easier, right? So with multiplication on the inside, we know that that is addition on the outside. So just algebra, this is the natural log of the first one plus the natural log of the second one plus the natural log of the last one. Now, because it's all separate natural logs, we can just take the derivative. So y prime is equal to no coefficients, so just the derivative of the inside, x plus 2 is 1 over the inside, x plus 2, plus 5x minus 1 is 5 over 5x minus 1, plus 5 minus x is minus 1 over 5 minus x. The plus and the minus just simplify to really being a minus there. This is our derivative. That's it. Okay? So then another example is if we have y equals the natural log of x plus 1 to the 9th over e to the x minus 6. If we want to take the derivative here, again, we should simplify first. So this is just algebra. Division of the inside, right, means minus on the outside. So the natural log of the top minus natural log of the bottom. There's more simplification to do though, because we have natural log of e. The e is inside of the natural log, so we can cancel them. Also, a simplification that we want to do of this first term, this exponent of the inside can be a coefficient on the outside. So it would be 9 natural log of x plus 1 minus the quantity of x minus 6. Because it's all x minus 6 drops down, because of that minus, we must put it in parentheses. Simplifying that out is just minus x plus 6. Now we're ready to take the derivative. So y prime is equal to, coefficient of 9 just gets rewritten, times derivative of x plus 1 is 1 over x plus 1. Derivative of minus x is minus 1. Simplifying that, so the derivative is 9 times 1, so 9 over x plus 1 minus 1. That's it. Okay? So maybe we might not have seen to do this simplification here. We would still get to this answer. Alright? There'd just be a little simplification to do in the middle. So multiple ways to get to the same answer. Alright? So, just to then recap all the different rules that we have. We have a power rule, which is some x to a power, right? Or we have the general power rule, which means we have a quantity of x's to a power, right? Or we have quantity of x's times another quantity of x's. This is a product rule. Or quantity of x's over quantity of x's, product rule. We have an e to quantity of x's, exponential rule. Natural log of quantity of x's, log rule. Okay, so it's all about where x is. If x is in the base, okay, then it could be any of these. Then you just have to see, okay, what's happening to x? Is it just x stuff to a power? Or is it multiple x things being multiplied or divided? Then, okay, x isn't in the base. It's in the exponent, so it's the exponential rule. Or it's inside of an ln, so it's the log rule, okay? So just make sure you know exactly what rule to use before you start any derivative problem. That's it, that's the lecture.